voting system. And so that's all around the around DC area. And so it's duplexed on the antenna. So these are the cans for the duplexer. And he's running about maybe 200 watts out of the PA. So that's 6 meters. Moving up to the top of the band now is this 900. This is a system I constructed. And basically we've got a number of satellite receivers. Right now we're running 2 active. There's this local receiver and a receiver in Northwest DC. And then we're using a Micor 900 chassis, high power amplifier. We got about 150 watts out to the duplexer. And so that's their 900 system. Tucked down underneath here, okay, there's a little computer which we use for IRLP, Internet Radio Linking Project. And so we can go on IRLP anywhere there's a repeater which says IRLP, get into the system, and you're up on 900 megahertz. So this is going to be changed out. I'm going to remove the mic cord. I'm going to put a Motorola nucleus, and that'll put out 300 watts solid state. So that's the upgrade that's going to happen there. Moving on to the right here. Now you're looking at, this is part of the 2 meter system. This is the 2 meter HPA, 350 watts out on this guy here. Okay, and with it, 2 meters has 8 satellite receivers, and we'll all go into an Astrotac voting system by Motorola. And the output of that goes into the controller, which is here, and then of course the output goes into the transmitter. Now this here, okay, this is new. We just installed this, and we're getting it operational now. So that's why I bought the meter and be able to test it out. We're going to fire this up today and make sure it's working after it was deconstructed and reassembled. It wasn't in a small cabinet like this, but we didn't want to do that. We wanted to put it in the real rack. So this is the. Yeah, we need to.
That's a nice picture.
Got it. So it puts out, I think, about 10 watts or so. That drives an IPA of about 75. This gets it out to 350 watts. So this is sort of a transition period between the mic core and the Quantar. And so the Quantar used the same kind of chassis, but they didn't have the amplifiers to go up to 100 watts. So they and then that's 7,000 amplifiers essentially to get there. So at any rate, that's where we're going. Moving over to the next rack, this is 220 megahertz, and for this we modified a Micor receiver. This was a 2 meter receiver, and we rewound the coils in here and changed it out. So we made this a 220 megahertz receiver. Modified the exciter for 220. Since we couldn't modify the amplifier, just we could go to 220. The way she performed. Tony built up a little module amplifier that's constant heat sink. So it puts out about 30 watts or so. 40 watts out of here for 220. No satellite receivers on that guy. And that's controlled by this controller here, which is about as old as Tony is.
That 25 years ago,
yeah.
30 years ago.
This is an MSF 5000. And you see how the amplifier looks very similar to this guy here. So this is a UHF. This is our UHF repeater. That uses this as a controller. The 2 meter and the UHF are PRC controllers, which are ISA plus controllers. They're old, very functional, but they can still work and keep on working. We've got a server in the shack, this guy here, and you see right now the Windows Media encoded in the repeater. So if you go on the web and you can go into Windows Media and actually listen to the repeater with the web. We got a monitor of the voting system, so as they're talking, we're getting a real-time readout of what receivers are being voted.
That's nice.
You can see it for the 6-4 one, so you can see it move all around between them. The other screen is the economic screen. We just added some modifications when the guys modified the air conditioning system. The system was basically a sealed tube, and the temperature was always running about 90 degrees, and they were constantly running the air conditioner, even in the winter time. So we turn it down a little bit so I can hear myself think. And so they modified the air conditioning system, and it's got sort of counter saver mode. And so that it'll bring in outside air, and the temperature out on the outside below a certain point will be 79 degrees. So below 79 degrees, okay, we're always circulating, we're always bringing in outside air to pull the shelter. There's an exhaust fan up there that pushes out the hot air, and these two amplifiers go to ducting, which goes to the outside. So hopefully we're not generating a whole lot of heat from those two amplifiers, which are really flowing a lot of heat.
Are you concerned with humidity?
Not really. It's really been a factor.
No, never a factor.
And so the way we're doing that, up here we have a little APC environmental monitoring unit. And that basically looks at two temperature sensors. One monitoring the outside temperature, and one monitoring the inside temperature, to be able to see what the two are. When the outside temperature reaches 79 degrees, then we switch the air conditioning system over from bringing in outside air to operating as a normal air conditioner. As long as it's hot outside, we're air conditioning the place. If it falls below 79, we're just bringing outside air. And we find that we can maintain the temperature of the shelter anywhere from about 79 to about maybe even 182 degrees. And it's been working,
And also,
working like a charm.
is that any of us can remotely get in and see what the temperature is. So remotely we can check it out. And we also have a remote feature, it won't here, it's right here. You want to tell them about the new APC we're going to adapt from the outside world?
Yeah, we can, let's go over here to look at the APC. So we have a lot of power failures over here. So we have an APC UPS, and you've seen this guy before. Okay.
We don't need to do that anymore, do we? What's your name and all that shit?
I'll tell you what. Let me go to the console because I want to see when the power failure was.
That's what I wanted to do too. Yeah, good. Okay, go ahead.
Okay. Now we're going to look at the power event summary here. Look at it at the last, let's see, the last 7 days. You can see what we have here.
It was what, today? Was it? When was it? Yesterday or yesterday? Not sure.
It mustn't. Isn't that interesting?
It's not there?
I don't see anything here. Part of analysis.
Huh.
Let's see what look like the last.
Yeah.
Moving on. Nothing here. This is a little commercial thing. This is the part, okay, of the actual repeater system. 8 satellite receivers. Local receiver 146.4. We have receivers in Damascus, Maryland, Brookville, Maryland, Oakland City, Northwest DC, Preston, which is really Mount Weather, Jessup, Maryland, and Frederick. So all these receivers all feed into that voting system, and no matter where you are in the area, you're going to be able to access the repeater. On the back side here are additional bank of Motorola receivers, and they go into this system here, which belongs to Tri-County Amateur Radio. And so we provide them with the ability to devote their receivers, then transmit it back out to their system on UHF. Moving on down, this is my system here. I'm also, as well as being on Ashton's committee and board, I'm also one of the founders of the Network Engineers Repeater Association, NERA. Okay, we have a repeater up on top of the WNU tower with a satellite receiver at WUS8 tower and a number of receivers around the state. And so that's all in UHF. But this is kind of unique. We're using this computer down here as a VoIP interface to Mount Lemon in Tucson, Arizona. So this is called a drill system, and it was designed by the guys in the Armadillo Amateur Radio Club down in Texas. And basically, it's a persistent VoIP connection. So if the internet goes down for some reason, it sits there and chugs along, says, "I'm looking for you. Where are you?" When the internet comes back up, okay, it makes a connection. And bingo, you're back in operation again. So we feed into the Cactus system on the West Coast. So you've been out in the LA area. Did you know Robin Critchell at CBS? Okay. Well, Robin was one of the founders of the Cactus Intertype, and there's about 200 repeaters on the West Coast, stretching from Montana, Northern, Southern California, into Nevada, New Mexico, Texas, and also now with our system here on the East Coast. They're all intertied together in one massive system, and you can reconfigure the system at will. So normally we tie into the Tucson, Arizona. Tucson goes to the switch in LA. So we hear the guys in LA all the time. And we can also bring up Dallas, Texas, or people in the Texas area, or we can enable Montana or wherever you want to go to. That's all done through this link here. And in addition to that, our system has IRLP. So this is the IRLP link into the nearest system. It's over here temporarily right now because it was sitting in one of the members' houses, and he's on vacation for a month. And as we found out yesterday, if the system goes down for whatever reason, it keeps the link transmitter constantly, so it causes the computer to stay locked up. So Tony was gracious enough to come out of his bath clothes there and come out here and reboot the system for me. But anyway, go over to the drill on the computer there. So we can look at all the systems here.
Larry,
Very good. That's a pretty good system. In addition to IRLP, Cactus Intertype, we're also tied into the dairy system. This is the Amateur Radio Interconnect. This was designed by some of the guys up in New York, Joe Muscio and Howard Price at ABC New York. And so we tied in with those guys. Now they have Bristol, Connecticut, New York City, Saraland Mountain in New Jersey, Philadelphia, now Washington, D.C., Disney World in Florida, Disneyland in California, and soon to come online is going to be Boston, Massachusetts. So basically up and down the East Coast and out to the West Coast on the dairy system. So we have two IRLP based,
you need the login?
actually three VoIP type of systems tied into the system. Yeah, let me with Tucson, and you can see we're now connected, and everything is cool. This gives us the COS status of us and whether we're transmitting or not. Why are we? Okay, I saw the heartbeat was going up, and that's not right. But it looks like it's connected fine now. We'll see if. N7CK WA3K, are you around, Mike? W7HSG, anybody out west available for a short demo? This is WA3KOK, Ashton, Maryland.
Good morning, W7HSG, Tucson, Arizona.
Hey, how you doing, Ralph? How's the world treating you out there? We got a friend here who was out in California for a while, and we wanted to show off the cactus intertie. How's the world in Tucson?
It's going to be a warmer one today, but we've had lots and lots of rain, so that's been good.
We're expecting rain today as well, although hopefully not at the degree we had about a week and a half ago. We had about 6 inches all at one time.
Yeah, I know a lot of people playing for a biblical epic to occur at Foggy Bottom, but it didn't happen.
Yeah, I think we'd like to see an event happening there on 1600 Pennsylvania Avenue. Maybe flood the basement over there.
Well, it'd take more than that. I mean, all of that area needs to go back to being the swamp it is.
Yeah, I think you're about right on that one. Hey, what can you do? At any rate, thanks a lot for coming back and helping us show off the system.
All right, very good. I don't know if California's out there or not. I haven't heard of them for a while. 56 people by day in Los Angeles.
Hey, hello, Los Angeles.
I gave it all.
How's your weather out there?
Yeah, for some reason, Larry, you dropped out, and also Ken dropped out mid-sentence, so I don't know what's going on. I don't know. He was coming in fine earlier.
So am I working now? Over.
Yep, sounds good.
Okay, it might be me fast buttoning or not hitting the microphone hard enough. You know, these things happen when you become a geezer.
Did you say geezer?
Yeah, I know the feeling well. Rapidly approaching it. Okay, thank you, guy. Yeah. Anyway, you're getting gas. If you're ready to be on
All right, great. Thanks again. We'll let you guys run. Take care. Have a good day, and we'll talk to you soon. WA3KOK, currently Ashton, Maryland.
Where's the rest of this?
Not a good district of confusion today. Okay, very good. W7HSG, just not clear.
Okay, so that you see how clear it is. The whole system is designed, around so that the audio quality stays consistent. There's no pre-emphasize, de-emphasize, pre-emphasize, de-emphasize with all the links. You pre-emphasize once in your radio, and de-emphasize once on the receiving side. Everything else is flat on the system.
For our conversation yesterday, and I called the Air Force keyboard.
So that's kind of what's happening there.
Very impressive.
So that's kind of what we've been up to. I mean, it's not rocket science, but we have a lot of fun at it.
We got to show up the tower before we leave, too.
Oh yeah. That's all omnipresent when you walk outside. Once we get the computer in, we've done a lot of cleaning up of the cable work behind the racks. It used to be the Echolink interface was sitting on a little breadboard circuit board, kind of hanging on the back of the computer. And so I said, well, if we're going to be doing this, we might as well heat it up a little bit. And so I fixed that up, got it working. So it makes a big difference aesthetically, I guess. It's not working any better, but it makes me feel better that we cleaned it up.
Switch in there so I can tell what current it is. The current coils are in the back of the panel. So I can flip that switch and find out which particular phase is drawing so much current. What I do is I got one phase I give to my neighbor.
Really?
And I take care of the other two phases here. And this sort of keeps it balanced. And this little puppy is ready to go. It should flip this and it should spin right over.
So, for maintenance, it's brushes, I assume, for the generator? Or?
That's a DC generator. It's externally excited, okay? And Maurice just got through cleaning up that commutator. And it looks really good. Oh, it's really shiny. but we gotta get new brushes for it eventually, you know, but.
No
Right
problem
now.
finding parts or something like that?
No, it's amazing. You still get parts from Caterpillar. Well, I had to rebuild the lower power fuel there. So and yeah, I put all the new gaskets in there. So you know, I mean, I still got those parts. Yeah. I could have made the gaskets, but and they were cheap, you know. So I didn't put a new valve cover on there. Now, when I first started up, usually what happens is that the injectors are, you know, once it runs though, it starts to purr like a kitten. Four-cylinder.
Yep.
It's old. And this is an old generator, the old engine, the 3400 engine, I think it is. And that was the same engine that was used in the D2 bulldozer during World War II. You know where the CBs used to have the bulldozers for the airfields? Same engine.
Wow.
Yeah. And this is the same kind of generator they used to have in the islands. You know, when the military, you know, got into the islands, they'd bring these little puppies in there because that was the only power they had. And they used to run these things, mix kerosene with oil, and run these things with kerosene from the dirty oil from the trucks. You know? So, you know,
Wow.
And I guess you just shut it down every 60 days to change the oil. Something like that.
Yeah. And that tank is a 55-gallon tank. And that'll let it run for about 3 or 4 days, depending on the load. But, you know, I've had it a long time. I mean, I had a real big leak now. It's dry as a bone. But, you know, the coupler's there from the vibration got loose there. But, you know, that's the generator. I run it for about 20 minutes before I switch everything over.
Oh, for that long?
Oh, yeah. Well, it's an old thing, man. I mean, you don't just get up and run, you know, when you get that old,
sure.
you know?
Well, as I remember, it smokes for a while and then it
That's right.
calms
the
right
injectors
down.
clear out. Right, exactly. Took it apart up in Frederick, Maryland. I took it apart here. I've got pictures of it. I sandblasted every piece of that tower right down to the white metal, and then primed it, and then put a finished coat on it. But of course, that's 20 years ago, 25 years ago.
And it took you how long?
It took me maybe summer and a half to completely sandblast. I almost got divorced. I'll tell you.
Yeah.
My wife would come out and says, "We're going out to dinner in a half an hour." And you know, when you sandblast something, you can't leave it overnight with the white metal. You have to put a primer on there
Interesting.
right away. Otherwise, that rust starts forming right away.
Wow.
So it was a project. I had it all set up over here and had it all put together. The bottom part, I had a couple guys help me with the bottom part because I couldn't lift that myself to put together. They were pretty heavy, those legs. But I've got pictures of everything. I took pictures of myself sandblasting out. It was a labor of love.
No doubt.
It worked out real well. It's been up for a long time. That cross piece up there, the holes for the VHF and UHF antennas, the cross piece, that is all solid material. That used to be rung 25.
Okay.
No good. Wind came along by and it just torqued it. Rung 45, no good. Torqued it. That stuff is all solid bar, solid. And that hasn't torqued in 90-mile-an-hour winds that we had, 85 mile an hour.